and these are some of my favorite math stories. In this episode, mathematics is magical. We look at a magic trick that is fun and easy to perform. You will need to have 3 books with you and some paper. Start by asking your audience to choose one of the books that you brought. Hand the book to one volunteer and hand a piece of paper on which you have written a prediction to a different volunteer. Then the audience will help you identify a word in that book. Ask them to give you a 3-digit number. I asked for 3 different digits so that the calculations to follow are a little bit more interesting. An example could be 347. You're going to mix up the number to further randomize it. So first reverse the digits, so 743. Subtract the smaller number from the larger. In our example, 743 minus 347 is 396. And then reverse those digits. So that gives us 693. Add those 2 numbers together. 396 plus 693 is 1089. And this is code for page 108 and word 9. Ask the volunteer to open up the book to page 108 and find word 9 and read it out loud. Then ask your other volunteer to read the prediction on the piece of paper. They match. I love this trick because it brings interest and intrigue to a basic bit of arithmetic. As some of your audience will probably guess, any 3-digit number operated on in the way we did will produce the number 1089. I'll show you why in a little bit, but to be honest, I don't find that especially exciting. So we'll be looking for word 9 on page 108. But how do you know which book would be chosen? Well, sometimes I have a good guess if I know what the audience might like and pair a good book with 2 drab ones. But I don't have to know which book will be chosen. Somebody usually suggests that all 3 books have the same 9th word on page 108. Have somebody take a different book and show that that's not true. So what would have happened if the audience had chosen a different book? Well, before doing the trick, find 3 books where you know what word 9 on page 108 is. Complications can be pages with figures and captions, formulas, or other situations where it's not clear whether to count something as a word or not. It helps if the words are somewhat interesting as well. The, or, are not much fun. Now here's a great book, and magic happens. I'd love to use one of my own books, but do plus minus count? Does that subsection heading count? If so, and MV passing is one word, then the 9th word is an. Here's a fun book that immediately grabs your attention. So pick out 3 good books, and for each book, write down the word on a piece of paper and stick it in a pocket. When the book is chosen, pull the correct piece of paper out of the correct pocket, and you're good to go. I find it amusing, and it usually gets a laugh, to answer, what if we'd chosen that book with, well, then I would have reached into this other pocket and pulled out this prediction. One time I did a similar trick with 32 possible answers, and at explanation time, it was fun pulling out 31 alternative answers from different pockets and sleeves and wallets and so on. It was a challenge remembering which answers were where, though. Well, let's see why you always get 1089. Try it for yourself. I'll show another example alongside the generic ABC. A, B, and C each represent a digit 0 through 9. You start with a 3-digit number. 843 is an example. ABC, generic. Reverse the digits. So 348 in the example, CBA, generic, and subtract. So we'll notice that because we've got 3 minus 8, we've got to borrow 1 from the middle. So it's actually 13 minus 8 equals 5. And that's always going to be true, assuming that A is bigger than C, which is the way you subtract these numbers. So on the C minus A, we're going to have to borrow 1, so it's actually 10 plus C minus A that'll be the ones digit. Now we borrowed 1 from the middle, so it's actually 3 minus 4. We have to borrow again. 13 minus 4 is 9. It will always be 9. And we borrowed 1 from the 8. It's actually 7 minus 3 is 4, or A minus 1 because we borrowed minus C. So generic is A minus 1 minus C, 9 in the middle, 10 plus C minus A at the end. Reverse the digits. The generic is now 10 plus C minus A at the front, 9 in the middle, A minus 1 minus C at the end. And then add them together. We obviously get 1089 in our example, but let's see what happens in the generic. Starting the ones digit, we've got a negative A and a plus A. We've got a plus C and a minus C. 10 minus 1, we're always going to get 9. So 9 plus 9 is 18. In the first digit, plus A minus A cancel, minus C plus C cancel. 10 minus 1 is 9. Well, 9, 18, 9 isn't really a number. We carry that 1 and get a 10, 8, 9, or 1089. Making this code for page 108, word 9, disguises what's going on a little bit and increases audience participation. It's a fun little trick.